Hello viewers, today in this video I will tell you about LoRa. LoRa technology is developed by a company called Semtech. It is a wireless communication technology offering a very long range with least power consumption. It offers a very long range and least power consumption. Now you must be wondering that if it is offering a very long range, then why does it consume least power consumption? Because it is based on CSS modulation technique. CSS is chirp spread spectrum. Now what this CSS does is, it is a kind of modulation technique that LoRa uses in order to consume very less energy. So this is the reason why LoRa consumes very less power. Now talking about the range. If I am talking about the range, then I will also bring in knowledge of bandwidth to you all. Bandwidth. These two terms have a very close relation with each other. Range of LoRa is greater than 10 kilometers, and if I talk about its bandwidth, then its least bandwidth is 0.3 kilobits per second, and if I talk about its max bandwidth, then it's 50 kilobits per second. Okay, so this is the least and max range of bandwidth. Now you must be wondering that what is this bandwidth? Bandwidth is actually the data rate. Now what is this data rate? Data rate is the capability of LoRa, that it can, how much data it can share in per second or in a fixed time. Okay, so why I am saying this, that range and bandwidth as a close relation, it's because I will draw a graph in order to make you understand. Yeah, this here is bandwidth, and this here is range. So we all have used Bluetooth, and one thing that we know about Bluetooth is Bluetooth doesn't offer very good range, and neither does it have a very good bandwidth. So we can maybe plot it over here. Okay, Bluetooth. See, you can see that it is below the, it is at, yeah, you can see it is offering a very less range, and meanwhile it's also offering a very less bandwidth. Bluetooth fails when we try to transfer video files because it doesn't have good bandwidth. Now if we talk about this Wi-Fi, then what we know about Wi-Fi is it offers very bad range. It doesn't have good range, but it offers a very good bandwidth, maybe 20 Mbps and likewise. So, and if I talk about modulation, or if I talk about a technique that offers a very good range and also a very good bandwidth, then it can be your 4G networks. Yeah, these offer a very good range and bandwidth also. Now what I have drawn this graph for is basically for LoRa. Yeah, LoRa. You can see that the data rate is very less as compared to Wi-Fi and Bluetooth. Now if I talk about LoRa, then it can be placed over here in the graph. You can see that range, it is offering a very good range, but when we talk about bandwidth, then it is offering a very bad bandwidth quality. Okay, so one thing should be brought in knowledge with this graph is LoRa can be used to share and transfer censored signals, right? But it cannot be used to transfer audio or video files. So suppose that this is your field and farmer's home is at a distance of any let's say 18 kilometers. Again a very bad drawing. Okay, yeah, 18 kilometers. Now here a farmer can use a moisture sensor which will indicate this farmer living at a very long distance. So when the field will lack water, then this LoRa module from you can say TX here over here, it will transmit a signal to this farmer, and this farmer will get to know whether there is lack of water or not. So it can be used to share censored signals, but not for bigger data like video files or audio files, because it doesn't has good bandwidth quality. Okay, now let's move on to the next specification of LoRa. Yeah, next specification of LoRa is link budget. Link budget is very important characteristic if I talk about LoRa. Yeah, link budget. So to make you understand link budget, I will take help of a quick diagram. This is a home, and here it has TX. Okay, TX, and it is connected with a cord or you can say wire, and this is antenna. Okay, this is antenna. Now here again this is RX receiver, and with a cord again it is using an antenna to receive signal. Yes, now this transmitter is sending some data. Link budget, let me first tell you the link budget of LoRa. It's 151 dCB. Okay, now you must be wondering what is this and how we can use this. Okay, so here we have this TX. Okay, and here we have this RX. From here the data will be transmitted to RX. Now if TX is transferring some data, some kind of signal to this RX, then it must be having some power. It must be releasing that signal with some power. Now this power will give a positive link budget, positive dCB value. It can be maybe around 10 dCB. But again, there is a wire. There is a wire and it will reduce the power. So it can be maybe like 2 dCB. But again there is antenna and it will raise the power. So it can go maybe up to 20 dCB. So yeah, 20 dCB. Now what will happen? This signal will travel in this open air up to receiver. Now when this signal will travel for a very long distance, just let me tell you one thing, that if the signal is traveling in an open air, then larger the distance, the larger power will be consumed. So you by this you can know that the power will be reduced. So if there won't be enough power at the receiver point, then receiver won't be able to actuate or to attenuate a signal. Yeah, so this way this signal transference will be failed and receiver won't function. So this is link budget. Now a basic definition, this is a practical definition that I have told you. Now I will tell you about the basic definition. Basic definition of a link budget is you can say there are some, this is gain, this is loss, and this is gain. Okay, so link this value comes by the sum of all these DCBs. Now to find out the link budget, or it is also known by direct budget, we can sum up all the gains and subtract it with the losses. So this will give the DCB value. There is a specific formula, you can look for it in Google. Now in order to make you more in order to make this more understanding, I will just take a help of one more quick diagram. Let's say this is TX, okay, and this is RX. So I'm using these values, and these are very practical. So here if you say this Tx is giving 10 dCB, positive 10 dCB, and this cord is giving negative 2 dCB, and again this antenna is giving 20 dCB. So when this signal will travel in air, and there must be weather, and it could be stormy, and there could be high speed winds which will hinder the power of this electrical signal. So this could bring a negative dCB value of around 150 something, around 150 dCB something. So this can really hamper the power. Now if this power, there is a margin over here, there is a margin line over here, this is margin line over here. Now if the received signal is not in this margin, then the signal won't run and the signal sending will be failed. This is because the weather can be stormy, or there could be high wind speeds. And another factor that can be accounted with this is it might maybe there are obstacles, maybe there are buildings, homes. So these can reduce the power transmitted from transmitter to the receiver point. Okay, so by this I have completed link budget. You can see 151 dCB is the value of LoRa. Now moving on to the next topic. Next topic is Fresnel Zone. Yeah, another very important topic. Fresnel Zone, specification of LoRa. So Fresnel Zone is basically the area that should be open. Now what happens? Electrical signal depends on so many factors. It must be open. In open spaces, in open air, the signal transference quality is very good. Now in order to, here this is Tx and here this is Rx. It's not like this is a road and you can place the receiver over here and Tx over here, and this is open air and the data can be transmitted very easily. No, it doesn't happen. If this is transmitter and this is receiver, then it assume a kind of ellipse. This can be the distance and this can be the radius, and height is also a part of it. So Fresnel zone is this area which must be very open in order for the safe transference of this of electrical signals or any kind of data. So if suppose that there are trees here in this section, or you can maybe say home or any plants or industries, and this much section is covered, and again over here this much section is covered, then data transference will not be good, and let's say it's 40% space is consumed. So the signal, so the power will be reduced. Let's say the power will be received at the receiver point will be reduced. So this is a Fresnel zone, a kind of ellipse that is also responsible for the spreading factor. Now again, spreading factor is the rate at which the data can be easily sent to the receiver. Now moving on to the next specification of LoRa is geolocation. Geolocation. Geolocation, what this does is, if suppose that there is a RX receiver and this is fixed in a moving vehicle, let's say a car. This is a car and this is transmitter or maybe, yeah, this is transmitter in a home or any organization or something like that. Now if you want to track the position of this moving vehicle, or it could be anything, it could be a aeroplane or anything it could be, so this transmitter can receive its location, its real time location on a map, and map, let's assume this is a map, and if this vehicles move in this direction, then transmitter can see the moving path of this moving vehicle. It could be anything, car or a drone or anything it could be. So LoRa is capable of doing so. Now let's talk about the frequency. The frequency that LoRa works on. So different countries have different frequency ranges. So for Asia, if I talk about, it is 433 megahertz, and for Europe it's 868 megahertz, and for America it's 915 megahertz. And another point that I want to conclude with it is the operating voltage. The operating voltage of LoRa is 3.3 volt. Now you can give from in a range of 1.9 volt to 3.5 volt. If this maximum limit is exceeded, then you will fry up your LoRa module. Yeah, by this I have covered the major specifications of LoRa. Thank you.